In this video, I will complete to illustrate the commands under the tool menu. Okay, SQL query command, simple query. First of all, let me explain some things here about my analysis. I didn't make any design. This is a simple span one story frame, and it's analyzed. Let's in the post-processing mode. Let's see the normal force. Normal force values are given here. I have member 1, this is member 1 between node 1 and node 2. That's the beam 2, that's the beam 3. I have just one node at step load. The length of those beams, let's measure it. This is 3 meter, 3 meter, and this is 4 meter, but we can also measure it. Let's make some explanations. This is 3 meters, 5 meters. Again, this column is 3 meters. Now the table of the normal force diagram is also provided at the right hand side, and you see along 3 meters we have here for the beginning section and for the end section of the beam 1. We have also results given for the intermediate section. So I have here given 1, 2, 3, 4, 5 sections. The normal force values are provided here in the table. I'm keying on about only the normal force because I will illustrate the usage of the command using only the normal force. What is the Fx? X is the local longitudinal axis of the member beam. 5. 1, 2, 3, 4, 5. Here in this table, when the information given in the table, every member is divided into 1, 2, 3, 4 into 4 sections. So into 4 lengths, into 4 segments. Sorry, every member is divided into 4 segments. So every member has 5 sections, and this distance meter also gives us also indicates the section number. It's anyway look like a section number. Informs us about the place of the section, about the starting end of the member. However, it gives us this information, but now we can think it also as a section number. Okay, so for every member at 5 section places, we know the value of the normal force. Now for member 2, the normal internal force is constant. It's 2.973, as you see from the diagram. It's also shown. And in the other column, the normal force has the same value. Since the structure itself and the loading is symmetric, the normal force values for column 1, for member 1, which is a column, and for member 3, which is also another column, is same as you see here. Okay. After these explanations, it's better to understand the results provided to us by means of query, simple query. Under tools menu now, I am using SQL query. SQL means structured query language. Structured query language. Computer engineers use those SQL language, structured query language, and they obtain data, extract data alongside data, and they make them tabulated or some data among a lot of data is extracted depending on some conditions. It's a language. But here the Staad Pro provides us a tool and a simple query tool. And by means of this simple query tool, although I'm not a computer engineer, I can obtain an SQL code, which allows me obtain, for example, normal force of all members depending on some conditions. Okay. Now I made a lot of testing queries before and they are saved here. Anyway, I can't delete them. I don't know. As I understood, they can't be deleted once they have been created by the user because there is no delete tool here, delete button here. Now let's create new query. I want information about members, and this information will be extracted from member tables, and it's about beam force detail, as you see here, beam force detail. From this table I will extract some information. I want to see member number, not section name but section. This means place of the section. It's not name, it's like a number, fx. And if I want to obtain the value of fx depending on some condition, I choose where, and this condition will be written depending on the value of fx, which is the normal force in the member. I want to extract the fx value, which is between some values, means that the fx is smaller than, here as you see, for example, I don't want to see 14, 13, for example, and there are also 12 here. I want to see values smaller than 12, for example, equal and smaller than 12. And also fx values equal and higher than. Now I look here, I don't want to see 2.973, 9 also, 10, higher than 10. Between 10 and 12, I want to see the normal force values between 10 and 12. That condition is written by this way. Let's click on done, and for all members, not for the selected members. Click on OK. Now this code is the SQL code. Normally a computer engineer with its knowledge can write it, but I didn't know anything about SQL language. I used this tool and the tool created it for me. Now to hide this query list, you can click on here. Sorry, query list. So the query list, you can click on here. We have nothing to do with it. And if you don't want to see this text, also you can click on here. If you want to show it, you can click on here. Actually, I don't need both of them. I can hide both of them. Okay. Now, new query is its code is created by me. This is the text of it. Now check query. Okay, it check no result is up to, no result appeared. Now execute the query. Now execute the query. Now as you see here, member 2 does not include any normal force between 10 and 12. Okay. But however, between 10 and 12, member 1 includes some values, and member 3 also includes some values. Now here division. So every member is divided into a lot of divisions, and into a lot of divisions. I don't know how much. Now I see here division for member 1, 2, 3, 4, 5. For member 3, 2, 3, 4, 5. For member 3, I have the value 14, but I don't see the value 12. It should be something here. So it's between 0.75 meter and 1.5 meter, something here. So the results which are provided to me is for a lot of divisions of members. Here in this table, every member is divided into 5 segments, but here the results are provided to me with a lot of divisions. I can't control it, but I can maybe obtain some more information. Without saving the query and the results, I will click on new query. And I try again, maybe number, section name, reinforced theory, section and ethics for all members. Now I want to obtain the results without writing any condition. Okay, staying on the safe side. The table, the provided query, the table provided by the query will show me how many division I have. Section name. As you see, section name is unimportant for us. It's about the property. But how many division one member has, as you see here, we have 0 section, a section given by division number 0. For member 1, its normal force is 9.417. Yeah, as you see here, 9.417. It's the starting section. And 12 is the last section. It has 14.719. 14.719. Now we see here the distance from the starting section. Here the division number is given. For member 1, 12 section, including 0, actually 13 sections are given. Now go down. For member 2, again 12. For member 3, again 12. So now I know the query divides or considers every member composed of sections with numbers starting from 0 to 12. Now I understood. Okay, let's create new query. Again, now can I do this here? This means that I want to, here the results are shown to me. How many points do I have? Including 0. 13 points. And among 13 points, I have 12 segments. So every beam is divided into 12 segments. Okay. Here every beam is divided into 4 segments. When the results are given. But I can't use any option, maybe because of my because I am lack of knowledge. I am still the learner of Staad Pro. Actually, I used it previously, but I want to learn it now in detail, and I want to learn its using of its commands in detail. Now, I looked and searched the program, and I couldn't do anything to obtain this table. Beam force detail here. Okay. I obtain it always so. I couldn't change anything. I couldn't, I searched for it, but I couldn't find any option, so that the results in table are provided to me by considering every member composed of 12 segments. It's automatically created, and in the created table, the information about internal forces are given me by considering every member composed of 5 segments. So four segments. 4 segments. Okay, I can change it. Now in SQL query, we have to select members before clicking on SQL query, simple query. Okay, I don't want to see query list, hide it. Now new query, member tables, reinforce detail. This is, I want to have this table with member number, section name. Section name is not important, it's the property. We have seen that rectangular section, it's about the section type. And section, which division, and fx. I have just one node case. And none for all members. Okay, execute query, as you see here. Now the same table obtained for fx. For the same table I can obtain also, but results are given for member 1. And member 1 is, every member is considered composed of 12 segments. Okay. So from this table, I want to use this table as a base instead of that one, because here I see on the 4 segments, I see 12 segments, and if I write a condition, the result is extracted from this table depending on the condition, and this table is more detailed than this table. But to be sure that those tables are same and they verify each other, we can say that the starting section of the member 1 has this fx value 9.417, and here 9.417 or 8. Okay. The ending section of member 1 is 14.719. You see the same result. And fx value in member 2 is always 2.973 blah blah blah. As you see, they all verify each other, all results. There is no need to speak about member 3 because it's okay. I watched it. Now I think this can be closed, but I want to take this table to Excel. I had the values in Excel. However, there is a problem. Yeah. Table captions or the column captions are not given. Member, division number, and fx. Okay, let's close. I want to close this table. So it confuses me because the information about fx normal force is provided by considering every member composed of force segments. Instead, I want to use this table. Okay. Now let's make query. I don't want to see the query list. Saved query, names of the saved queries. A new query. I want to have information about members and reinforce details about number I want to have. That section number I want to have. I know there are 12 sections. So 13 sections starting from 0 section ending with the 12th section. And I want to obtain, now I don't want to see all those results. I want to obtain I want to see if I want to obtain fx values between 10 and 12. Between 10 and 12 means that I will see on this in 10 and 12. So this one I will not see any one of them. And this one. So sort them. To obtain those values sorted instead of doing it in Excel by watching I and deciding the values, I can make it from here, sorting, extracting those values. The sort condition depends on the value of the fx. I want the fx value smaller than 12 and fx value higher than 10 for all members. Okay, executed. Now let's check between 10 and 12. I have some values here. I made a mistake when I am writing it. I made a mistake, sorry. So fx smaller than 12 and fx higher than 10. Done for all members. Do it again. Okay, let's control. In member 1, at sections 2, 3, 4, 5, 2, 3, 4, 5, and their values changes from 10.3 to 11.62, correct? And again, only in member 3, in sections starting from 2 to 5, in member 3, in sections 2, 3, 4, 5, and starting value is 10.3, ending value is 11.62. Okay, correct. This is to use simple query. If you want some information about results, this could be information about geometry input values also. You can obtain this information as well as from tables, or you can obtain this information depending on some condition using simple query tool. You can obtain also that results After you obtain that result, this result, you can click on Save Query, give it a name, Query 8. Okay. Now show saved query. Okay, query 8. That's my query. You can also save query result as a report. It will be a report. Give it a number, an ID, title. Let's say query 8, ID 8. Okay. Now I had an error here. I don't know what happened. Let's close this. Can you see this report here in the reports? This is report setup. Input, reports available. What are available? What items can I see in the report 3? Now get rid of it. What results do I want to see in the report? Among items available, input items. Input items are those items. Basic load cases, support materials. The inputs, loads, reasons, supports, inputs that I enter to the software to make analysis. Input information. Output information can be obtained. Reports and advanced query reports. My report is simple query. From the simple query window, I click on create report, but this report will appear here, advanced query report, as not simple query, as advanced query report. Okay? Under advanced query, I have a lot of reports. Those reports. There was an error. I encountered with an error. I don't know, the last one was here. I don't know. Every time I create a report, okay, let's send all reports here and say okay, and now see the report. This is not what I have created. This was from my previous studies. Next page. Next page. Next page. So there was an error there. The report created is not there. Simple query. This is the last query. It's already saved. Save query result. Title advanced query. Save report advanced query. I say nothing here. Say only OK. I get an error. Maybe it's about my program. It's about my program. I couldn't obtain any report file from here because if I arrive here among outputs, I don't see anything about my query, simple query results. Only advanced query reports are provided here. And among advanced query reports, I see nothing. Maybe it's about my version. I couldn't do anything. All those reports were created by me before. Okay, say cancel. Now let's use advanced query. Let's say before that, customize advanced query database. You know, advanced query database is full with information. If before calling advanced query tool, if you cancel, if you uncheck some boxes here, it works. It works easily. Advanced query tool is launched easily. For example, if you don't need beam, for example, I don't need plate information, solid information, surface information. Those things cannot be unchecked. It's not allowed by the program. Now I am erasing some information from the advanced query tool database to be able to work it faster and to be able to launch it faster and easier. Analysis results. Among analysis results, I don't need. I need node shapes. I don't need. For example, plate results. I don't need. Solid results. I don't need. Surface results. I don't need. And I didn't make any design. I don't need design results. Okay. So they are all unchecked. Okay. Customize advanced query database. Now I customized advanced query database. Means that when the advanced query tool is launched in the program, it takes less information from Staad Pro, so its launching time gets shorter and its working time is easier. Its working load becomes lighter. So I click on OK. Tool, SQL query. Before launching advanced query tool, it's better to click here and uncheck the data which you will not need when you are making advanced query. Okay. Okay. Now this time make simple query. The same thing can I do here with beam results. Beam and forces. Well, I'm searching for beam force details. Beam section force. Yeah, beam, I'm searching for beam section force. As you see here, under load number, every beam is divided into 12 segments. Section number 0 corresponds to the first section. Section number 12 corresponds to the last section. And fx is provided for every section. Other informations. Other internal forces and moments are given here. Now here the data is provided with beam number, load number. I don't want to see load number because I have just one load. Section number, section mark. I don't want to see section mark. As you see here, the last section has the section number 12 and the first section has the section number 0. Others have the section mark or section name. Intermediate section mark actually is section name. I don't need also this information. I just want to sort the normal force. And click on here, run query, provide information. Now this is a bit more easier to see. You see the table. The table is provided for member 1, 2, 3 composed of 12 segments. Now here write the same condition. This means at condition. Now the condition will be written for fx. Fx, I want that fx is smaller than 12, not just 12, and again fx higher than 10. Okay. Now with the condition sort, as you see, I obtained the same results. Now check it with the Excel table. Only in beam, I have in section, only beam 1, I have in section 2, 3, 4, 5, those values, 2, 3, 4, 5, starting from 10.3 and ending in 11.62. It's correct. Or for beam 3, again, for section numbers 2 to 5, yes, 2 to 5. Yeah, again, same video. Remember the column, both columns, because of the symmetry of the geometry and the symmetry of the loading, the results are same for beam number 1 and 3, which are the solely only columns in my structure. Easy structure is used to make it understandable. That's okay. And SQL language is here. Okay. Having what for what this is used, I don't know. That's okay. So let's save this query with the name. Give it a name. What to say? Let's say okay, that's it. Okay, this query is saved here. Saved report, automated report generation. The report, since this is clicked, the report of it is automatically created. As you see here, on the from the simple query tool, I couldn't create any report, maybe because of my version. My software is anyway broken. But we have seen report 1, 2, 3. All those reports were coming from advanced query tool. Now report 4 is created when I save this query automatically, since here is clicked. Okay, now I will leave here, exit, and come to report setup. Let's advanced query airport. I see here report 4. So I have only report 4 in my report. Let's preview my report. As you see, the table I created by advanced query report 4 is here in my report. So we have illustrated using simple query, advanced query. So continue with configure user tools and user tools. We have user tools. We can call some programs or some executable files from here. Using configure user tools tool, some executable files are added among user tools, and they can be now called here. For example, this is a executable program which is used to export this model to be used in autopipe program. Okay. Staad input file name is this. And in autopipe neutral file, it will have this name, job information, some informations are used. And then you click on OK. And our file is converted into saved with an extension which can be opened in autopipe. Some another tool is export module to SAX. SAX is an software used to analyze offshore structures. Now our model will be saved with an extension and converted into a file with a different extension, so that it can be opened in SAX, and our model can be opened in SAX as an offshore structure and can be analyzed or designed later than in this program. Okay. Now, those tools are added here as default, comes with the Staad program. Now I want to add another program, for example. I have a unit converter. I want to special unit converter, my own program. I want to call it inside Staad Pro now from here. Menu items. Let's say here my unit converter. It's command. Sorry, it's in my hard disk. Let's find this executable unit conversion file. Where was it? Yeah, it's here. It's not Visual Basic macro. It's an executable file. Okay. Open it. No arguments and no initial directory is used to launch this program. And I don't know for what this initial directory is used. Let's say OK. Tools. Users. Now configure user tools is used to add unit conversion exe file to here among user tools. You see the sixth program executable file or Visual Basic application file called from outside of the Staad Pro is my unit converter. As you see, it works. Okay. Okay. And what else do we have to teach? Connection tags. Connection tags is not easy. Here, for steel structures, connection of beam column or column beam column. There are a lot of different connections, and those different connections are done in Staad program using the RAM connection mode. And in this RAM connection mode, playing with these buttons, making some arrangements, you place between your columns, beams, some connections, special connections described here. They have descriptions, and then you can say these are connection tags, and those information about steel connections between column beams, beam columns, column beams are called connection tags. The information, this information is kept in the connection point between beams, columns, and blah 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 in Staad program. And this information is created using those tools. And after that, the information about those connection tags is saved using Staad program. Or the same information can be created in another program. Okay, this type of the connection the information about the connection bolts, connection welds among beam columns can be also created by means of another program. There are other softwares for designing steel structures and their connection types, and can also be saved as connection tags. And once this connection tag file is saved by using another program or Staad Pro, it can be loaded from here. Load connection tag file. Okay, and then after loading, it can be edited, viewed, and checked. And those things are subjects which shall be repeated or which shall be done, like I mean here using this command, illustrating using this command can become after learning using RAM connection mode, and after learning using design of steel structures and design of the connections of steel structures. As a result, I end here illustrating the commands under the tool menu, and thank you very much. Please subscribe.